Good evening, everyone, and welcome to another virtual DDD meetup. Today will be slightly different because we're having Carola here with us, doing a hands-on legacy live coding, and hopefully people in the breakout rooms are able to join us. So welcome, and with me, of course, Christina, as fellow organizer. Sorry, I forgot you there. And yeah, welcome, Carola, and thank you for joining us.
Thanks, Kenny. Hi, everyone. Still people getting in. So what we're going to do tonight is I have a Miro board for you prepared where you find where we will work together. There are slides as well. I will talk to you about this and that, what I find in legacy code. And in the description in the abstract of this this talk, there is already there is a link in there to GitHub where you can find the source code yourself and even program yourself. So we can live code all together. And the first thing is I'm gonna send you in the chat. The link to the Miro board and the password, not surprising, is this. Please try to go there. And I hope I can see you in a second on the Miro board. First person in here. Please come to the Miro board.
Trying, but it's loading at the moment for me.
Oh, it's loading. Yeah.
Yeah. So, hopefully. It's not the same as last time that Miro decided not to work.
Oh, well, they are already sick.
Ah, there it goes.
Yeah, you're coming in. I take you all to my screen so that you can see the entrance area. And I would like you to click on one of those thumbs up. So please tell me how much you know about DDD. Are you a beginner who knows just some terms? Are you an advanced person who is using DDD in your own programming? Or are you even a professional who is teaching DDD to others? Kenny, are there more people coming in?
Yeah, we make sure that
Christina's
making sure and we're spamming the chat. Because, and also people on YouTube can join. And maybe you need a refresh. I needed to refresh Miro at some point. So try that.
Yeah. So most of you, I took you to my view. There is the entrance frame. If you don't know Miro, on the left side down there is a button called frame where you can click on and you can select the first frame, which is called entrance. And if you select that entrance frame, or you just I just bring you to my view, then you see those three possibilities and if you click on the thumb up, it will count you as one person who is a beginner or advanced or professional. And like this, and if you click twice, it takes away your selection, you know. Yeah, some people already clicked on the thumb. We are getting forward. That's nice. We have 4 professionals, up to now 6 advanced people and 8 beginners. This is all fine. 37 people on the board. I just bring you to my view, all of you, so you can see the entrance frame where I want you to click on one of those thumbs. Okay. Okay, getting some more clicks here, but there are a lot of beginners, and this is absolutely okay. We will try to work together on an example, and I will start with some slides. You can keep the Miro board open, and you can click on the thumb later on. And to show you the slides, I decided to do it on the Miro board, and I will share my screen. And I will share my screen with you, because otherwise you don't see how I keep on going with the Miro board. There. Okay. So here we are. Now you should see the Miro board on your screen where the slides are located. And I'm gonna hide all your little marks so everybody can follow more. So what we're gonna do today is we're gonna look at a legacy system, and we're gonna try to do some coding and discuss different possibilities how DDD can help us with legacy code. And I'm gonna present myself and my company. These are all my colleagues who work together with me at WPS in Hamburg. This is our last big event that we did in summer 2019. The next event in 2020 was different, as you all probably know, because today we are like this. Like all of us, in the end, we are just working remote, and I'm very happy that we were able to do that. So I don't know how it is in your company, but I have like 15 different teams programming, and we were able to switch to remote work in 1 or 2 days, and it works. So I'm very, very happy that we all got this working together, and we can sit here and discuss software in groups from all over the world. What I'm doing, my name is Carola, and I'm managing director in this company, but as well software architect. And I did my doctor thesis on complexity of software architecture, and all the stuff that I did for my doctor thesis, like looking at various software systems, I put into a book, which is a German book in the beginning, but it has been translated to English. And I'm very happy to show you some bits and pieces from this book as well, because DDD is very, very close to what I have learned in my time at the university, and later on in looking at various software systems. In my company, we actually do DDD since 2004, since the first book of Eric Evans was released, and my colleague Henning Schwendner and I, we have translated the book of Vog Vernon into German. So for all the German participants, there is a German version of Vog Vernon's book, and we had a lot of fun translating it. And we discussed a lot with the DDD community in Germany, how we would translate bits and pieces in the book, what is the right word. It was a big discussion in the German community. This was a lot of fun. Okay, and okay, so what I did for my book, and since then, is we are looking at huge software systems with tools, and I will show you some little diagrams of tools like that. And what you see here is a sum up of sizes of software systems we have seen. So out there are a lot of small software systems up to 100,000 lines of code, some more up to 500,000, and a lot of systems are about 1 million, 5 million, 15 million lines of code. And this is so big that people need help to understand these systems and have a clear and simple architecture to get around. And DDD is actually offering us a clear and simple idea how an architecture should be. And around the diagram in the middle, you see various programming languages we have been looking at. A lot of object-oriented programming, of course, because we already have a lot of legacy code in Java, in C#, in C++, of course, but also TypeScript starts to get older and older, and a lot of PHP software is out there too. And when we look at legacy software, we often find systems that look a bit like this. The people started with a good idea in the beginning, and they did the first part of the system, and then the software grew and grew more and more and got more and more, well, complicated, badly organized. People were building little bits and pieces, and nobody really thought about a good architecture. And I think this is as well because when we all started to create huge Java systems, we didn't even know what we were doing. We were just trying to get source code done. And inside of these systems, we often find structures like this. All the rectangles, all the are classes, and the colors mean that they come from different components, domain components, and this thing is a real cycle. So wherever you come from, you can get to all the other classes and the way back, and you can't get this thing really apart. You can't separate those tangled classes into proper modules or something like that. They are strongly connected, and this is a huge problem in legacy code that you might know. And I thought a lot about how can I show people in a simple way what they can do if they have structures like this, if they have to live with structures like this. And the first or the best way for me to do this was to create a simple example. And we're gonna look at this simple example now. I will unshare my screen in a second, but the simple example is here next to the slides. I put the source code here, and I put a little diagram here, and I'm going to explain this diagram to you before we start to read the source code, because here you see the structure. And this picture is from my most loved tool for architecture analysis. It's called Photograph. You might have seen me talking about architecture analysis with this tool. And for me, it gives you a very good idea how this little example is structured. So what do you see here? This system is a Java system, and we have two packages, application and models. And in there are files, and in this case, those files are classes. So we have a credit service class, an account management service class, a credit account class, a credit class, an account class, and a customer class. So these are the classes, and if you think about the names, oh yes, this is a bank example. And on the other side of you see some arcs, and these arcs represent the dependencies between those classes. There are some on the left side, and there are some on the right side. The reason for this is the arcs on the left side, they go downwards. So the credit service is using the credit account, and the credit service is using or has a relationship with the account and with the customer. So on the left side, it goes downwards, and on the right side, it goes upwards. And you can see that the customer knows the account and the customer knows the credit and the credit account. So down here, there is quite a cyclic structure if you look at it closer. And what I want you now to do all together on this Miro board is that you look at the source code, or you can do this in your Eclipse or IDEA development environment that you already prepared with this example. And I want you to put marks on the Miro board, little things like this, and write down what is not good here. You can put it on the source code or on this yellow area here, all the pain points that you find in this source code. Okay, so I will stop the sharing, and we are all on the Miro board now, and I invite you to look at the source code and put your ideas, what is stupid in here, what should be different, onto the source code or onto this area on the left. Go for it. And it's no problem if 2 or 3 people write down the same thing. Doesn't matter. Just do your own stuff. Very nice first ideas. Wonderful. Mm-hmm. There are already errors between nodes. Cool. Sometimes these sticky notes are a bit hard to write into. You have to double click on them, and then it's easier to write. Oh, and notes on sticky notes. Very nice as well. Comments on sticky notes. Some new people are coming in, I think. We are working we are using a Miro board. I can put the link again into and the password into the notes, the chat. Oh yeah, no tests. That's right. Although in my source code example, we had
Is it
some.
good to share the Miro again? So
Yes, I put it in there just then, 2 seconds ago, but
no,
maybe.
I mean share the screen so people can see the Miro board in the YouTube stream as well. Who are just
Yeah, good idea. I can do that, so people can see how everybody is working on the Miro, because it's pretty impressive. All the nice little stickies appearing. Transfer money is not thread safe. Yeah. Hi. Someone just came in. Christina put in again the link to the Miro board where we are just working on, and the password. So whoever is new, come in, read the legacy source code and put sticky notes on it or other kinds of marks. I mean, you're very creative, very nice. And the slides that I showed on the left, but I don't think they are just pointing out who I am and so on. So you don't need to look at them first. You can directly jump into the horrible source code and tell me how horrible it is. How you would hate to work on a thing like this. Yeah. Welcome. We are already working on some horrible source code on a Miro board. The link returns 0. Oh, Try it again. There are 45 people on the board, so for most of you, it worked. Maybe refresh, yeah. Myra wasn't informed about the meetup. Yes, I'm sorry for that. But I think 47 participants on a Myra board should not be a big of a problem for them. Okay, another 2 minutes, and then we're gonna try to do something about legacy code. Myro probably doesn't want to show you this horrible source code. Another minute, and then I will ask you to stop creating sticky notes or comments, and we will all together look at the result and start a first step of refactoring. Oh, inheritance is evil. How nice is that? Okay, last orders, please. If there's something very, very important, please write it down. If not, just slow down and let's look at all the things you said. Okay, I will start on the right side on the little orange area, and I will call you all to my side. So, attention, please. Fluff. Okay, let's have a look here. We have several, we have no tests. Yes, in the GitHub, there are some tests. I didn't put them here. I already said that. I think we have the account management, creating customers. We can discuss that. We have a not thread safe transfer money. There's nothing thread safe in the whole thing. I think the account balance can be negative. Yes, that's true. And there is a very one sticky note with a lot of remarks, very complex account management service, customer entity has a list of accounts, which is very bad. Yes, we may use object values for money instead of primitive types. Object values is something we're going to talk about. This is a DDD concept, no business validation, yes. And down there, a bit the same. We are using int, a primitive type, in the transfer money method, and the debitor account number as a credit account number, since they are both of type int. Yes. So there's a lot to do in this example, and we will slowly move over to the source code on the right side and have a look for other interesting remarks. There's, yes, someone put a yellow mark there. We have an anemic domain. That's true. All the classes are with setters and getters. That's the service does all the work. Very true, and we should change that. This is part of what we're gonna look at. This class has several responsibilities. Also true. A lot of primitives, yes. You can always create new customers. Is this a good idea? Why use Java time data of birth? This is a good question. I mean, this is legacy code, so you can find anything bad in there. I'm gonna go a bit down to some other remarks. What if this fails? That's a good question. There are no checks, nothing like this. And down there is a remark of someone who is not a Java developer, and who, this is really true. You can get the account number list and you can change it outside of this class, which is not such a wonderful idea, not in Java, not in any other language. That's true, but I've seen this a lot. I'm gonna move on to some other things people said. Would be logical to be able to create an account with balance. Yes, there might be a lot of logic that I just wanted to keep this example small, which I didn't program into the example. This is true. The account depends on the customer. And the customer has an account list. Exactly, we have a cycle in here. And then the customer has a credit list. If you move over there and follow the arrows, I think Christina put them in there. Too much information, amount, customer, credit number. So they are all connected with each other. Do we really need all the getters and setters in all the models? Yes, very good question. No consistency, that's true. Why a setter? It should never change. Yes. So you saw, I hope I valued all your messages here. You are very right. This is a horrible example, and we have a lot to do to get this into a better shape. And I will call you now to the screen where I have the steps to a better architecture. Wait a second. Click. Oof. Oops, this should go. This is not. The thing is slow today. Okay, so the 5 steps that we're gonna do to refactor this source code to a better solution is, we already started with understanding the legacy, finding problems in there. Very good. Now we're gonna look whether we can divide this problem into 2 smaller problems and have bounded contexts. I know you might start with something else, but bounded context is such an important concept in domain-driven design, and it already helps this small example that I want to start with this step. Later on, we will define value objects. We will change the domain model towards a richer domain model. And finally, we will get rid of cycles. Of course, you can do these steps in a different order, however you want, but in a group, we will do them like this. So the first thing we're gonna do is we're gonna think about refactoring the system to at least 2 bounded contexts. And I invite you to look with me on this shared screen now on the second part of the slides, where we will do the hands-on bounded contexts. So now please look at the Zoom shared screen so that you can see the slides and how I move through the slides, okay? Okay. Whoops. This is not what I wanted. Okay. So what we will try to do now is we will try to understand what's the idea behind bounded contexts, and what we will do in the end is divide the source code into 2 bounded contexts, accounting and credit. And we will do this in a second on the microboard. This is where we are heading for, and I will show you 10 slides, and then you know why and what this means. Domain-driven design has 2 main methods inside. One of them is to do strategic design, and the other one is to do tactical design. And we will start with strategic design. Strategic design has the idea that we can separate our source code, our huge legacy source code, into smaller bits and pieces. And in domain-driven design, these smaller modules are called bounded context. And a bounded context is a domain-specific solution of some part of what our software should do. And the idea of domain-driven design is to combine these bounded contexts on a context map. And the context map helps us to know in which part of the software some functionality should go and how they should talk to each other, these bounded contexts, how they are related, connected to each other. If you go a bit further and think about what we have learned in the last 15 years since domain-driven design, since the first book was written, we learned as well that it's a good idea to have one development team for one bounded context, and to help this development team to focus on the functionality, on the domain-specific parts, and really create a consistent domain-bounded context for some users. And if we really want to scale, we could go further and have a microservice for a bounded context. So this is where domain-driven design is heading for. And well, the idea here is to create different bounded contexts. In there might be some technical layering. So there's a user interface, an application layer, and a domain layer, and the database. And between those bounded contexts, there is loose coupling, which means as little coupling as possible. And we will talk about this as well. From my point of view and all my colleagues, the very important message of Eric Evans is that a bounded context should be a module which can live on its own, which does not need a lot of information from other bounded contexts. And we will try to look at our example in this way, even if it is a small example. Whoop. Next slide, come on. It's a bit slow here, the thing. But this is my role, this is not me. Okay. The goal of this cutting the source code into bounded contexts is to have one domain model for each team, and each team is working on its own domain model and has its own limits and boundaries, and is just working inside of these boundaries. If we think about our example, we could think about a bounded context accounting, and a bounded context credit, and each team should have all the classes they need for their bounded context, and they should not need to share their bounded context. And the big problem I see all over the place in legacy software is that the domain model is one. There is one domain model, and there might be some applications on top that are separated, but the domain is one big thing. And we can't get it apart. And in the small legacy example that I have given you, you can already see this problem. This is a classical problem in legacy code. You have a domain model that has multiple intermingled mental models in one, and it's really an unmanageable complexity. And you have dependencies among teams, like those animals on the right side who are from a funny German book for children. They eat some bread which is connected with a string, and then finally they all die because they don't get away from each other. And this is what happens with the classical domain model. The teams are connected, and they try to change the domain model for their changes they need, and all the others have to work with that. And this is our example. We have, if you remember, we had an account, we had a customer, we had a credit class in there. There might be some security bits and pieces that we have not even programmed yet. And on top, there is account managing and credit business, and the account managing knows the account and the customer, and the credit business knows the account and the customer and the credit, and so on. And we have to get this apart. And to get this apart, we have to separate them in their own bounded context, and actually have the account twice. We need the account in the account managing, and we need the credit account in the credit business. And the customer needs to be duplicated in some sort of way as well. And we need a credit customer and a customer. And this is the big change that I see with legacy code. which is really, really hard if you already have some bigger source code base. In our little example, this is quite easy. Okay. And we will go now into our legacy software again. You can open it in your EDA and start to program and get it apart. I will start here with some people in the main room, and I will organize you some breakout rooms. So whoever wants to work on its own can do it. I will stop the sharing, and I will create. We are like 40 people here. I will create like seven rooms, and you will see in a second the possibility to go into the breakout sessions. Can you see that? Down there, some new icon should have appeared, and you can on your own go into a breakout session and start a group there and one of you should share their screen, and you should start to program something like 10 minutes to get this source code apart. And now I'm waiting for you to go. You can go into those rooms. Orlando has done it, and Maria, some people are leaving and getting together in the rooms. This is great. Ken came back with his camera on. Yeah. In Zoom, you should have a little icon to go into a breakout session. In room 1, there are already 2 people, in room 7 as well. Yeah, in room 7, there are now 3 people. In room 2, the first person went into that room. Please join Alpa Henkendi in room 2. That'll be nice. He's alone. In room 1, there are already 3 people. Someone is going to room 2, maybe? So he's not alone? You know, we all have learned to be self-organized teams, don't we? Just go there and work with him. Oh, someone is doing it. That's nice. Ron is going to room 2. Very nice. Someone else getting into some breakout rooms. Maybe everybody else is working on their own. That's possible, isn't it, Kenny? Okay. Okay, 3 people in room 2. That's nice. There's as well, there's the Miro board, and there's the link to the GitHub where you can find the source code. Yeah, again and again. And you can try to get this thing apart into two bounded contexts. Okay, the other people in here, 26, you want to go somewhere or into some breakout room, or you're just listening and it's fine? Oh, Claudius doesn't want to go anywhere. No, he says. At least someone who is talking to me. Okay. I will share my Eclipse with you now, and we will as well try to work on the story. And there you can see that there are...
Wait, some people cannot... I'll allow participants to unmute themselves now. So now people can start
now
unmuting
you can
themselves. Yeah, we did that at the start so that people dropping in wouldn't all of a sudden barge in. That sometimes happens in these
How
open...
horrible. Like this, you feel like someone...
Good that you say that, Claudius. Thanks.
But now you should be able to do it, aren't you? So, I mean, in the rooms, they are unable to talk. This is probably not possible, is it?
No,
Nah,
so here it works, I guess.
Okay. I mean, this would be strange.
I will go to the rooms and check quickly, and I'll be...
Thank you, Ken.
So you can continue.
Okay. Okay. So I'm gonna share my Eclipse workspace with you. Here we are. We're gonna start over here. This is the first version of the source code. Like anybody should have it with the account managing service, the credit service, account credit, credit account, and customer. And down here are some test classes. So, Anna Maria, please.
We are not able to share the screen in the rooms.
Oh.
It seems to be disabled.
Okay, Kenny. We have to get Kenny. Wait, thank you. I get out and we have to find Kenny. Where is Kenny? This is something he did. Where is he? Kenny is in there. Wait, I'm gonna go there. Okay. Kenny is trying to fix it for the breakout rooms, and we gonna work together. You can talk now, I think, can't you? We changed that, no? You can speak? Someone?
Yes, I believe it works.
Oh yeah, I hear you. Very good. Okay. So my Eclipse workspace is coming. You should see it now. Yeah?
Yes.
Yes. Okay. So what should I do? We should work together. So tell me what is the good first step to do from what I told you before, what we want to do. We want to divide this into two bounded contexts. What should I do? They are old other stuff here.
Create two packages, maybe. I don't know.
Good idea.
we can start to define the bounded context is
okay.
Like the models folder. We can split it to some kind of two different module or package. It's a good start, I guess.
So I will. This is a very good start. Thank you for pointing this out. So I will just create a package. Counting and another package
maybe credit,
good idea. Okay, oh, small. Okay, perfect. And now
then let's start the move account Java file to
put it there, no?
Folder.
Yeah. Okay, I'm gonna do it. Okay, so account manager is in accounting now. Perfect. And the credit service, I guess we put it to credit, shouldn't we?
Yeah.
Yeah. Okay, so now we can already get rid of application, which is nice. I'm gonna delete it. Okay, and now the model. This is more complicated. You remember I told you this is very often like that the model is one model for all different bounded contexts. What should we do?
We can start to move account and the customer Java file to related module, which is accounting.
Yeah, so I start with the account. I put the customer too.
Yeah.
Okay. And the other two sounds like they should belong to credit, don't they?
But the credit is a very generic name. Can we put
Yeah.
it some better naming convention? I don't know.
Yeah, let's have a look. I mean,
it belongs to customer, right?
The credit.
Mm-hmm.
Well, I mean,
Not if we want separate domains.
yeah. We want separate domains. Yes, we want an accounting domain and a credit domain.
So I think your original thought of moving credit.java and creditaccount.java to the credit package makes good sense.
Makes good sense. Okay. From my point of view too, I just gonna put them there. Okay.
So in a sense, we've moved the specific models to the specific packages. And so now the models package can go away.
Yeah, I'm gonna delete it. Okay. So now we did this, and I think on the Miro board, you can even see a first version of this that I did with the tool. I'm gonna share that with you. Wait a second. Up. Stop. And I'm gonna share Miro again with you. Okay. You can see it down here. I hope you can see it. What I did with the tool is I created a bounded context credit and account, and I just moved the classes within their packages into these two bounded contexts. This is almost what we did in in Eclipse just then, but what you see are all the relations in here now. No, the credit is using the customer and the account and the credit account. So we have a lot of tangled relationships between those bounded contexts, and we have to get rid of them to have two separate bounded contexts. What should we do? What could we do to get these things untangled here? What could we do?
We should maybe duplicate.
We
No.
should maybe duplicate. No.
We may create a like credit customer ID or account ID. We may use some value object instead of just direct reference between each other.
Yeah, this is as well an idea, but the let's have a look in the source code again. Wait. Okay. We were just looking at the credit service, no? And if you look at the credit service, he has credits, and he if someone applies for a credit, the customer gets in here, and the customer is put into the credit. So it's pretty difficult, and if we get into the customer into the credit, we can see that the credit is storing the customer, and you can even get the customer from here. I mean, we would have a lot to do to change this at that point, towards a customer ID, and we haven't even learned about value objects yet. So my idea when I created this example was that we actually start with really duplicating duplicating classes, just to get them apart and to reduce them on their way, to get them more specific for their bounded context. If we do it the other way around, we still have
Dependencies.
classes with all the functionality there, you know? Can you understand my argument?
Yeah.
Yeah.
How about we can use customer ID, just the ID, just primitive types instead of duplicated class?
Yeah, but from my point of view, in the credit area, we will need a specific credit customer. If I think at large legacy source code bases, you need a specific customer for that bounded context as well. In this little example, we can just create some customer ID and live with that. That's true. But if you think into the big, a credit customer is something different than a customer who only has accounts. You need more information about them. They need some securities for their credits and so on.
Yeah, makes sense.
Yeah, okay.
So should I close the breakout rooms?
Yes, this is just what I wanted to say. So we discussed some stuff, and we will stop the sharing here, and we will stop the breakout rooms now. Should we tell them before? Oh,
no,
they
will...
get the information. Okay, that's nice. Okay. So I'm gonna share Miro again. When they come back, they will see this. We just give them another 4 seconds. 3, 2, 1. Hello again. Oh, they are all. This is so funny with breakout rooms, no? Coming back and. Did you stop all the breakout rooms?
It was one button. Stop all the breakout rooms.
But because there are still people in room 2 and in room 7, no?
I don't know how they are doing it.
Oh, and
No,
we are in
they're all
room
gone.
1 now.
Yeah, that's interesting.
Something.
But everyone should be back now.
Yeah. Okay.
We can recreate them later. And then,
Yeah.
You might
Zoom
have
has
a
its,
1 minute timeout.
No, the countdown is 30 seconds. And it's off. So
Okay.
it's
So
very interesting. It's a
back,
leak,
okay?
security leak.
Okay, I hope you're all back. If not, we're gonna find you again. So now we go back to the Miro board. I'm gonna share it with you, and we have all of you have did their best to work a bit on the legacy code. I know at the beginning it was difficult because you were not able to share your screen, but then I think you could discuss some stuff. And what I want you to do now is to go to follow me to the second hands-on frame bounded context, and to put some sticky notes there to explain what you have done. What did you change? Because we had some discussion here in the main room as well. We can put some stickies on the board as well, what we wanted to change and how we discussed it. So what did you do? What did you change in the source code to move it to refactor it towards bounded contexts? Yeah, someone did duplicates. Mm-hmm. Mm-hmm. We are on frame 2 now, second hands-on bounded context, and we try to share the information between the groups, what we did. Oh, someone really was able to create a customer, credit customer. Very good. Oh, they even duplicated all the models for both. Mm-hmm. Aha, someone did what we were discussing as well. Yeah. 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 Okay, so most of us did similar things. Some of us, we all created 2 bounded contexts from the existing source code, and you duplicated the models. Some duplicated, and someone said they replaced all the direct references by IDs. We discussed this too in our group in the beginning, and I said, well, I don't want to do that now, because then you hide the relationships between the domain models, and you don't know anymore afterwards how they are connected, and you actually want to reduce each domain model class into its context. But I would like to hear some of the arguments of that group who did it. Is someone from that group here and can tell us what did you exactly do? Did you put the customer into the accounting, and in the credit you replace the customer reference by an ID? Is it this?
Hi, I just went off and did it by myself.
I
started to poke around the code.
Yeah.
So I have, over the years, I've become like a value object and data access object kind of guy. So in my head, everything is basically just an ID or a service.
Okay. Okay.
That was the approach. For the connection between the contexts, I thought that the credit customer would know the ID of the accounting customer.
Okay. A possibility, but you created a credit customer class, nevertheless.
Yeah, I stole that idea from you. You mentioned it before.
Yeah, no, it's okay. It's okay. Yeah, it's always, I have to give some information, and then people are doing their proper thing. Okay, so to finish this part, I'm gonna show you the solution that I created. Whoops. In this little example, there is this frame second hands-on solution you might see on the screen and on the shared screen as well. And and I will, this is just two slides. So this was the structure we had in the beginning. And in the repro, you will find my solution, which looks like this. In the first place, I divided the whole thing into two bounded contexts with all these references between. The credit service is using the credit account and the credit, and the account is as well using the credit account and the credit. So this was the first just rearrangement, and then I actually created two packages and put the classes in there and duplicated classes. So down here you find a credit customer now, and I cut the connection between account and credit account. If you looked at those classes, some of you put a sticky note on the credit account and said inheritance is evil. This is I'm absolutely with this sticky note. In the domain model, inheritance is really something you should never do. And what I did here was I copied all the logic from account into the credit account to create a proper credit account class and to reduce it towards its needed functionality as a credit account. You can even have this without any connection. So in the end, this is the question for later. How do they work together? But the first step was to get them really separated apart from each other and duplicate the customer and cut the connection between account and credit account. So this is, you can find this in the repro as a solution as well. And we will go to the next step now, which is the step with value objects. We already had the idea of value objects in our in all the things you said in the last few seconds, and I want to get with you into the topic of value objects now, and I will explain to you what value objects are and how you should use them. I will show you a little example, and then we can discuss it, because we have some people who are beginners with domain-driven design as well. Okay, value objects in general are basically a symbol for a value of a certain type in the domain. They symbolize the same value if they are equal, and you can't change them. So what you see over here are several value objects, which are actually objects in the runtime system. They all represent the same value. So if you would compare two of these objects, the result should be they are equal. They are the same. And with value objects, you can do calculations. Value objects can consist of other value objects, but they can never consist of entities. They can never have entities in them. I will show you a general idea. So normally it's like this: an entity, which is a real domain class, like what we just saw, customer, credit, account. They have value objects in them. They consist of value objects. And some of you already said we need value objects. We have this balance in here, which represents which is representing the amount of money that is on an account, and this should, of course, be a value object. We look at this example here. Imagine we have the account, and we have this class account, and there's the balance in there. In this on this slide, it's just int. In the source code that I gave you, it's float, but whatever, it's not a great idea. And the question is, what can we do? You already put this on the legacy code as well as a note. Can a balance have a negative amount? What is about euro or British pound? What is this? The amount is just a weird number. And what we need then is we need a class amount. which is a value object, and this class should have some variables inside, of course, the amount and the currency, which is probably another value object type. And what you can normally do with a value object, you can create it, of course, with like this, and then normally you can ask for a new one with a class method, and you can compare them with equal. This is normally what you can do with a value object. And then there are some domain specific things. Hash code is, of course, always needed. You can add an amount to another amount. This is something what you do with amounts, so it's domain specific. And if you look at the implementation, what you see is that you will get another amount if you add two amounts. And this is the logic of value objects. Value objects never change. If you want to add two of them, you get a new one. This is what happens with strings, for example, in Java as well. And you can put this value object into account. You can change everywhere the int or the float to amount, and the set balance method as well. And with this introduction of value objects, of value object classes, you get a much more domain specific interface of the class. It's not the wonderful interface of a rich domain model yet. We have to work on that. But the value objects already help us a lot. And what I want you to do now is I want you to think about the source code and look at, get back with me to the frame where we can put some sticky notes. And I want you to go with me to the, I'm gonna call you all to me. Okay, what I want you now to do is I want you to put sticky notes here. Which kinds of value objects would you refactor in this little legacy example? What do we need? I mean, I already proposed amount, but there should be other stuff. What else do we need? Go for it. Oh, we are on the wrong board, are we? I wanted to be there. Ah, just do it there. It's no problem. I'm sorry, I took you to the wrong board, but we're gonna do it here. I'm just gonna move them afterwards to the right place. Just do it. Just put your stickies here. Account number, customer ID, nice. Account list, oh, account list, this is interesting. Kenny, you will have to explain that. Credit state, very nice. Date time, yes, of course. Perfect. Customer details, Okay, some more sticky notes are appearing. Ah, name and birth. Yes, yes, I understand. Date of birth, yeah. Family name. First name, yeah. Payment. Nice. Not all people have first and last names. Yeah. Really? Okay. Thank you. Kenny, you have to explain. Account list and credit list should be
Yeah.
value objects. This is new for me. Please explain.
So I'm a big fan of object calisthenics, and there's this thing, number 4, it's called first class collections.
Okay.
So if you now want to do anything with account list, you get the DSL of a array list, right? So everything you want to do with array list. So if you do account list dot, you get the API of the array list in Java.
Yeah, that's true.
Which is not a account list similar to that first name is not a string. So it seems a bit more work, but let's say if you want to ask something to account list, for instance, give me, I don't know that much of the domain yet, right?
Yeah.
Give me all the accounts with number, blah, 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 blah. That then you can, if you wrap it in its own first class collection, then you can write code for that so that people can just see account list as a domain type, which is a VO in
Wow. So, I mean, I have never seen that, but I think it's really great. If you have any link to that concept from whatever website, I would be happy if you just put it there so people can think about that later. There is several lists here. Thank you. That's perfect. Thank you, Kenny. There are several ideas here, and I'm very happy you put many things that I as well programmed into the next solution on the board. And as far as I can tell, I would always go so far to wrap all the integers, reals, all the standard types in my domain model that I can find into. I would wrap all of them into value objects. So in the end, there should be no int, real, string, character whatsoever. And the enums as well. I would as well create a value object class for that. For me, this is just a rule of thumb, and I'm always trying to do that to get my domain model more domain specific. This is the idea here. And what I think value objects do too, they help me to check on the border of my domain domain model whether the data that gets in is in the right format. You can't put a number as a first name if you have your own account. If you have your own value object class for the first name, of course. So there is a protection for your domain model if you are using value objects. So I would always suggest you to use value objects, even if you have no chance to divide your system into bounded contexts. This is a very, very basic thing anybody can do, and I think you should try to do that. I created. You can find the source code for that in the repro, and I can show you the solution is on the screen now. You can see it. The two bounded contexts. In the first place, I get you all towards me now for a second. In the first place, I have created a package value objects. You see account number, amount, credit number, customer number, and they are used by the two bounded contexts. This is something which we could discuss. In domain-driven design, there is the idea to have a shared kernel between two bounded contexts, which is a bit the opposite to what I said before. I want to create two bounded contexts that are not connected with each other. By this solution, I connect them again. You can see it. The value objects down here are used by the credit bounded context. There are arcs that go down there, and there are a lot of arcs as well from the accounting that go down there. Obviously, because the account has an account number and the credit account has an account number as well. There are different ideas about that. We could as well have an account number in the accounting and another class account number in the credit, of course. Some experts are here, some people who have done a lot of domain-driven design. Maybe we can discuss this a bit on that level so that the people who are new to domain-driven design can listen a bit to us. What do you think? Is it a good idea to have the value objects as a shared kernel between accounting and credit? What do you think?
I would say at that level, it is still safe. But this could change.
Yeah.
Because at the moment you could even take this from some public APIs.
Mm-hmm.
Amount it's money. I'm sure that there is a public API or an XML schema or something saying the currencies are all public. They will never change.
Yeah.
And amount is amount. So the difference is, but already there you could have a difference. Already there, I would say, if I'm sending you an invoice and I'm sending it in euros, and if I'm working with it, then I'm working in cents.
Yeah. That's
it
true.
is a huge difference depending on my context.
Yeah, that's true. Of course, this is, and so, sorry, Kenny, it's you?
Yeah, no, the danger is when you want to have within amount. So I've worked in a financial asset management part, and one domain wanted like, oh, we round up to 2 decimals. And then another one was like, we round up to 10.
Yeah.
And it's like, okay. And if you have a shared kernel, now you're going to have a bad time. So what Christina said, right? It depends on context. You can start with it, but as soon as you're having the discussion, 2 people want something different. Okay, now we split.
What I don't really, I never put this question because why should I do this? What are the costs to write these 2 classes or 4?
Yeah.
Nothing.
Yeah.
And I get for this a huge independence, and nobody is doomed and nobody has unexpected behavior.
Yeah. Yeah. Daniel has lifted his hand. Zoom is saying, Daniel, where are you? Say something.
Hello. So when I looked at the value objects, it seemed like sharing amounts between the domains seems fine, but account number, for instance, even if the concept is the same, I could get confused and use a value from one domain in the other domain.
Yeah.
And I would just the value of that number, it would be referring to a different account in that context.
Very good point.
Sharing, having them be different types prevents that error.
Yeah, very good point as well. The account number for credit might be something different than account number for an account. This is what you're saying, isn't it? And you get confused if we use the same class in both bounded contexts. Exactly. And
I like to add something else. It's very similar, but you know, that value object values means something else in the different bounded context. In this example, it's very obvious. All these value objects are referring same thing, but different contexts. According to ubiquitous language, it does mean something else on another bounded context. So the shared kernel is a bad idea, in my opinion. It causes a dependency between each other, and it does mean something. Yeah. So.
Yeah. So very good arguments. If you ask me, I'm in general as well against shared kernels because Alpha wrote it down in the chat as well. Dependencies between bounded contexts, that's something that we hate, exactly. And the name is strange as well. You are absolutely right, Geoffrey. It's called value objects. Well, what's this of a strange name for something that we have in our subdomain here, which this is really true. But Julia is saying, but we will have so much duplication. Yeah, but this is always the question: will we really have duplication? Because maybe this is what Daniel said before, and I think he could be right. The account number, or the other person said that too. The account number means something different in the bounded context accounting and in the bounded context credit. That's absolutely possible. And there might be a different logic for those two account numbers.
I like how Paul Reiner explains on duplication in connaissance. So duplication is only there if there's a connaissance between the duplications. So if I need to change one, I need to change the other.
Yeah.
And well, you only split if you don't. So going back to Julia question, right? If I duplicate it and I don't need to keep them both in sync, then it should be fine.
Yeah.
Well, that's my heuristic there.
Yeah. Luis, you lifted up your hand.
Yeah. Hi. Yeah. So just wanted to ask. So I guess this doesn't prevent us to maybe have one bounded context that is shared between others, or is that a bad idea? Something like common behavior.
Well, I think this is a point where, I mean, in the domain model, or in the classes that represent something from the domain and that are not technical, I would always try to get around a shared kernel, you know. I mean, I put this here to have this discussion, of course, you know. I would never claim that this is the good solution, because domain classes get more specific if they are kept in their bounded context, and they can be as specific as possible for their domain, for their bounded context. If you share them, you have to deal with the problem again and again that we already have today with those huge domain models that are shared between different functionalities. You know, I mean, in the beginning we had a huge domain but we had a domain model that was shared between the account service, the account managing service, and the credit service, and this sharing creates classes that are huge in general. In legacy code, if I look for the big classes in a big legacy source base, it is very, very often the domain model classes that are very big. The customer is very big because all parts of the system need the customer. And if you create some new functionality which has to do with the customer, you take the customer class and you put the methods in there that you need, or the new fields or whatever. And by this, the customer class grows and grows and grows. And all the different bits and pieces of the system only need part of the interface of the customer class. And this is a real problem. You know, the thing gets bigger and bigger, and much more difficult to handle, to understand. Christina, your hand is up.
Yeah, I wanted to say, I know the feeling. I know the feeling if you come from only the technical part. We always learned, do not duplicate. Duplication is bad. At the moment, if we start thinking about the business, we are in different teams working different parts of the company or of the platform. The first time, we don't know about duplication because in our context it's not duplicated.
Yeah.
The second part, don't be afraid of it. It is priceless to have not be coupled. It is priceless. It is not a problem to have 20 lines of code or 100 being somewhere in a code base is duplicated if I can deploy alone, if I can evolve alone without the being afraid to break something else somewhere else.
Yeah. And the main problem I see comes from what we learned in university or in programming classes or whatever. They always say, you have to reuse, you have to do reuse. If something is already there, you should reuse that class. And this is why the customer class or whatever, one of the main classes in the domain model gets bigger and bigger and bigger. And this is what we learned, but we should do reuse only with technical classes, not with the domain classes. This is another heuristic that I'm trying to use wherever I can. So
similar with generics, right? Or making something generic that's always being promoted as well.
Yeah, that's true. Yeah,
that's true. Not per se really good at some point. Yeah. So yeah.
When Anna Maria wrote, when things become extremely complicated, you need to separate, so you need to duplicate. This is true. This is exactly what we are saying here. Yes. Okay. So this is a first step to have value objects, but the next step would be to have them in their bounded context and to duplicate again. Okay. Okay. So let's go on. I'm not gonna repair this this panel now, but we're gonna go on to the next, to the fourth step, to the rich domain model. We will be able to do that in our session today. Okay, come on. Okay, I get you all towards me over here. Oh, I don't have to get you here. You can see it on the screen. What we want to do now is we want to move towards a rich domain model, towards rich domain classes. And this is just a joke that I love so much. I don't know if you know Geek and Poke. This is a German computer programmer who is creating little funny comics. And this one is about how to create a stable data model. And one of them says, since the requirements are a little bit unclear, we took a more generic approach. And then you have thing has something to do with thing. This is really funny, I think. And I really saw a system built like this. They had two rows, two entities in the system. One was called entity and the other one was called relation. And the whole system was built like this. And they had performance problems. So it was really frustrating. So please, yeah, this is just a joke, but don't do this, okay? Be as specific as possible. And when I talk about a rich domain model, I'm trying to get you away from an anemic domain model. And the example that I showed you, the legacy code, of course, is an anemic domain model. What is this? How can you? What is the specific of an anemic domain model? You find a lot of domain classes that only have setters and getters, and the domain knowledge is not in the entity classes, but in the services or in the UI. And I remember one of you put a sticky note as well on the board that all the domain functionality is in the services and not in the entities. This is exactly how systems like that look like. In systems like that, you often find a lot of util classes, helper classes, manager classes. I think I saw so many helper classes in the last few years. I don't know, people like helper classes, but anyway, this is a different story and we will go on. So what do I mean? If we look at our account class, we had this set balance, get balance interface. And I told you, well, for a rich domain model, we want to get away from that. And what we're gonna do is we're gonna make this interface more domain specific. If you talk with someone from the domain, they will tell you that you don't set a balance on an account, but you deposit money and you withdraw money. And this is actually the domain specific behavior for this class. And what I always try to do is I try to find proper domain-specific names for the methods in my domain model. So at least the setters are strictly forbidden. Of course, I have to ask for the balance sometimes. So a getter is fine, but for the setters, you should find other domain-specific names. And I'm a big fan of preconditions. Christina, I wish I could set a balance on my account. Yes, yeah, to some wonderful money. So what I always want to do is I want to protect my domain model from misuse. And this is just the beginning. We can check preconditions. I hope some of you still remember Bertrand Meillet, a French programmer who wrote a wonderful book about object-oriented software construction, and he invented design by contract, which is an idea that a class should protect itself by contracts, and these contracts are expressed in preconditions and postconditions. Preconditions are already a wonderful story. So this withdraw method protects itself by asking that the amount is bigger than the balance. So this account, that you can never withdraw more than the money which is on the account. It's not a credit account, it's a normal account. Oh, okay. And if you look at the amount class, you can have preconditions as well. If you try to add two amounts to each other, you remember we created an amount class before, you can have a check if both currencies are the same, because of course it's not a good idea to add euro to pound or to whatever kind of other currency that exists in this world. And this is the amount type is in there, and we can even use the amount class to check whether the amount that we want to withdraw is not less or equal the balance. So we can do a lot with preconditions and with proper names for our methods. And another thing that I want to put into your perspective, I don't know if you know the law of Demeter. Oh, there is still some German on that slide. I'm very sorry, but I'm gonna explain this to you. This is a principle that was invented in a project called Demeter, which is already very old. But what they tried to explain with this law was that you should never take some data out of a class and work on that object that you get and go on. So this is a little example for that. Imagine you have a student object, and the student object is storing the results of the tests that the exam that the student has done in some kind of structure inside. But at the interface of the student, you can ask for the record where the exam entries are stored, and you can add the result for some kind of course that the student has taken, and you just walk from object to object downwards and add the result at the end. This is really, really horrible. This is something you should never do. It's called, you should never walk down into the object structure to do something with a last object in the line. So what they say about with this law is, if you delegate fully. So if you ask the student to get his entry exam stored, you should delegate this fully in the first step to the student object and don't talk to a stranger. So we look at the solution, where this is done the right way. We should have at the interface of the student, we should have a store method, and should put all the data in. We want the student to store, and then the student is doing his work inside. So we have delegated the work to this student class. This is the law of Demeter, and from my point of view, this makes a class and a domain model as well much richer. And I remember some of you already put a sticky note on the board like that. Why can we get the credit or the customer list outside of our customer and our credit class? And what I want you to do now, is I want you to look with me at the source code again and find the possibilities to create a richer credit and a richer account class. And for this we will go back to the legacy code on the top. Wait a second, I guide you there. In the first frame, we had the legacy code, and I take you there. I call you. Okay, now you're all here. And let's have a look again at this source code and think about what I told you about the rich domain model. And I want you to put, I mean, the domain model is the account class, the customer, and the credit. Those three classes. We don't think about the credit account. Just put some stickies over these three classes. What you would change so that they get more rich. I mean, Christina, you did a lot of nice sticky notes in that direction already. You can just put them a bit over the classes, and we discuss when we can have a look at that together. If you find some sticky note that you did already, just put it on top of the frame up here somewhere, and what would make them, those classes, those three classes, account, customer, and credit, richer? What should we do to get them into a richer shape? You can just take your old sticky notes as well and just move them a bit up, and then we talk about them. That's fine. I don't want you to do unnecessary work. This is not the case.
It is not that, but I have so much problems with this class today.
Yeah.
It's hard to forget it. Like customer get credit list, add this.
Yeah. I really did all the nasty things.
Yeah.
You know.
It is a magic.
Yeah.
It's not easy.
No, I know it's not easy. It's not easy to even think about how to. Yeah. Maybe we should write them new. Oh.
Maybe.
Sometimes this is the solution, is it? Yeah. Yeah.
What I actually need is the reason. So what's my story? Why I want to know, why I want to get the customer out of the account. This would be the method to say, give me the account name or the name of whom this account belongs. So then I have a method called get customer name or something.
Yeah.
And not returning the customer, but returning the name.
But I really see this a lot, you know, because the people generate their domain model from the database, from the data.
Please stop.
Oh, you don't want to hear about. But someone said that before. I remember as well that there was a lot of functionality as well in the credit, and maybe I mean, this is as well something we could get down, you know, to make them richer. I mean, this is something which I think it was here somewhere.
It's the same. The credit returns the account, returns customer returns, everything. This is a real
disaster. I know. I'm sorry.
There is a name for this kind of huge models, binding them all.
Yeah.
Big ball of mud?
No, this the whole stuff. No, no. For models, there is a name for a model which is doing everything.
Oh, a God class.
Yeah, God class. This is very near. It does not seem because it has only 60 lines, but actually it has everything. It couples everything.
Yeah, that's true.
Yeah, this is just they just did you a favor of splitting into several classes.
Yeah,
but actually, you could just write this in one class.
Yeah.
It'll be the same outcome, right?
Yeah.
Now it's a better outcome you can see.
Yeah. So what we absolutely gonna do, which I told you already about, is we're gonna change the methods of the account to withdraw and deposit. This is something that we will absolutely do. We will try to hide. I mean, if you think I spoke about the law of Demeter, if you look at the customer class, there's a very, very strong validation of the law of Demeter at the bottom. If you follow me down there, you see get account list and get credit list. This is really something that should never happen. You go into the customer class and you get the lists of things that belong to the customer outside. Impossible. You should never do that. The same with the credit class. You can get out the status. You can set the status. This is something which is really stupid. But who is doing that? Why should we have set status? Well, then let's go over to the credit service, and the credit service is actually doing this. In the grant credit method. Can you see the grant credit method? It's in the middle of the credit service. And there, with the credit number, this method takes the credit object and sets the status. So this is actually something where you should really see that the whole domain functionality is in the service, and we should transport this to the credit class and have a grant method there. You can see it. And we need this as real. I mean, you want to grant the credit. Yes, this is something you want to do. So you need this in the credit class. Okay, so this is a point where we should as well absolutely change this domain model. And oh yeah, down there in the credit, I mean, I did a lot of nasty things, didn't I? In the make payment method, you get out the balance and do the payment, you know, by setting the balance. So this is really very nasty as well. We have to change that as well and move it into the domain classes. Okay. So what we did now is we spoke about the domain model, and the last thing that we didn't do is we didn't work on the cycles yet. Christina already pointed them out to us. I will do this with a little wrap up and just go with you back to the solution for the third hands-on. I'm gonna ask you all to come to me. So I mean, you can in Zoom, you can see my screen anyway. So it's not the case that I need you all there. But what you see here was the solution with the value objects in one package, which we discussed deeply, but you can see the cycles here. In the credit bounded context, you see cycles between credit account, he knows the credit knows the credit account, and the credit customer. So they are all like a database model, like a database model connected with each other, and up here the customer and the account as well. And if you think that cycles are not a good idea, and this is something that I do think a lot, you should end up with a model that rather looks like this. And this is really a discussion about the domain. Who should know whom? And I decided in this solution that the customer knows the account and the credit customer knows the credit account, but not the other way around, which doesn't mean that I could find the customer if I have the account ID, you know, the account number. Of course, I can ask a service to give me the customer for an account, but I don't need a connection between them, even not with an ID. You know, I can just walk through the customers and find the account, you know. So this is really something that you have to discuss with domain experts who should know whom. And sometimes it's difficult for them because they say, well, an account should know the customer, but actually they mean an account should know the customer number. This is no, so this is a different story. It's very hard to discuss with them to really come to the exact words, the exact names for what they are talking about. But I just want to give you the energy to do it, because afterwards you have a very clear and cycle-free model. And this is, from my point of view, a very, very good idea. So
if I can give one hint.
Yes, please.
What I do all the time, I'm asking about the behavior.
Yes.
Like not who has to save the customer, but what do you think, and which place or which team should make sure that the customer can change his address, or
yeah,
things which only customer can do, and it's surely not the credit team.
Yeah, that's a very good hint as well. It's a very good idea to always ask who is sort of who is doing what with whom. You know, this is what you said. You know, the behavior is always the question: who is doing what kind of action with whom, and then you find the behavior, and you can see the direction of the relationship between the classes that should be there. Okay, so this is what I wanted to show you in this session here, and I hope you had some fun tonight. You know where you find the source code. The slides are here on the Miro board. You will have access for another 2 or 3 days to this board. Then I will change it again for another group, because I'm doing reuse with the Miro boards. Thank you for coming. I would love to have some feedback. If you still feel able to do it, there is a whole lot of area underneath the steps, and I would love you to create some feedback. I'm gonna give you a frame for it. Oh, there it is. You have a frame for feedback. And if you still have the energy, just put some stickies on the feedback frame, please. Oh, thank you so much. Oh, yeah, I didn't talk too much about entities, I know. Ah, yeah. Yeah. Yeah, I just answered this one question. How do I make the model rich and delegate business logic to the entities without creating God objects? This is a very, very good question. Thank you very much. Because I talked to you about the customer who is getting bigger and bigger. And this is why you have to divide your domain into bounded contexts and have the specific entities in there. And of course, I mean, I'm not a fan of one bounded context per aggregate or entity or something like that. So in what I see is I discuss, like Christina said, what are we doing with this entity? What are we doing with it? The account, we withdraw and we deposit money. But other stuff that is connecting the account with the customer maybe, or is doing some logic on both of them, that should really end up in a service. So there is always as well some logic in a service. In my constructions, there are services and they have some domain logic as well, but just the logic which cannot reside in one entity. And this is, of course, a domain discussion about the domain logic. And we are discussing this a lot in our teams with the customer, forth and back, to get to a solution or to a design where there are no God classes or God objects, so that the logic is well divided in the right place, in the right entity, and in the services where they belong. But yeah, and I always look for the big ones. I always look for the big ones and cut them into bits and pieces. So this is of course not a wonderful heuristic, but design. This is why we are not just robots. We are designing good domain stuff. This is the point. I hope. Yeah, thank you very much for your wonderful feedback. I'm really touched. This gives me the energy to do it again, because of course the virtual story is much more difficult from the speaker's point of view than a real talk in a real on a real conference. But someday we will be able to do that again. And I thank you all so much, and I wish you a very, very good evening. And you can reach me on Twitter or via email if you have any questions or if you need some more information. Thank you very much. I'm gonna stop my sharing now, and
yeah,
I
think your Zoom crashed a bit there.
Yeah,
There's a problem with
yeah, but you can hear me still. Okay.
Yeah, we can still hear you.
Thanks
so thank
for
you,
having me, Kenny. Thank you very much.
Yeah, so thanks for being here.
Yeah.
And thanks everyone for joining.
Yeah.
This was really helpful. And thanks everyone for watching, also everyone on YouTube. You can go to the website and you can click through. There's we added the comment section. Me and some other people like Christina now working a lot on the website, trying to collect all these resources, and you can continue the conversation on the website. So yeah, go there, and also you can like the session as well on the website and interact with us. So please do. Thank you, Carola, again for your time and your effort. It really was a really nice explanation to people.
Yeah. Thank you so much for your patience in the beginning with the breakout rooms. There's some trouble with some techniques. This is how it is.
Well, then you know it's live.
Yeah, that's true.
So thanks, and I'm going to close the live stream, but I'll leave the Zoom session open so we can continue a bit of talking. So thanks everyone for watching, and see you next time.